worksheet. Problem 1, identify the inside and outside function of each of these composition functions. Well, that's super important for chain rule. You gotta know what inside outside is. So like here, inside is this guy, 4x plus 9x squared. Right, and if you take that away, there's just like an x here that you're subbing into, so it's radical x. Y equals tan of x squared plus 1. Say that when I say of, that's your inside. So inside is x squared plus 1, and the outside, just make that an x, so tan of x. This one's tricky. That one's a tricky one. So y equals secant to the 5th of x. So the key here is that this is written in a shortcut way for publishers so that it's easy, or for people also, so it's easier to write. This is really saying secant x to the 5th. And that's the key. You want to write it like this. Or at least think about that in your head. So when you see this all year, you want to think about, okay, secant squared, sine squared, it's written like this. So now the inside is pretty easy. It's the secant part. Secant x. And the outside, just make this an x, x to the 5th. Next one, y equals parentheses 1 plus x squared to the 4th. We'll just read my inside. 1 plus e to the x. I'm not sure why I said x squared earlier. Anyway, outside would be, make that an x, x to the 4th. There you go. 2, which can be differentiated easily without the chain rule. These can we do without the chain rule. So the first one, I always think about it like, how many x's do you see? So that's why I want to think about this. So like, how many separate x's do you see? So like here, like look at the second one here, there's 2 separate x's. This is not a chain rule. This is a product rule. So this would be a product rule. Same thing down here. Notice the 2 separate x's. That's a product rule. Up here, there's 1x inside. Even if this was a 2x, I'd still consider it one connected x. So this is not. So this is a chain rule. Only way to do this is by chain rule. There's the inside, there's the outside. That's a chain rule problem. This is a quotient rule. You can tell by the 2 separate x's. So that one, again, we're circling the things we could do without the chain rule. This one looks complicated. There's 2 separate x's, so there's a product rule, but all of that is inside the radical. So it's actually a chain rule. It's like a chain rule. It's a product rule inside a chain rule. So that one's, yeah, that's hard. Then this one is no, so only 1x. This is sine of x inside the e. This is a chain rule also. So only those 3 could be done without the chain rule. The rest are chain rules. And get used to it. We use chain rule a lot. It's also one of my favorite rules of all life, which is a derivative of f of 5x. So now a lot of people overthink this. They tend to freak out on this one. It's not as bad as it looks. So what's the chain rule? Take the derivative of the outside. Well, what's the derivative of f? Easiest thing in the world. F prime. Look how easy that is. Derivative f, just f prime. Leave the inside alone. 5x times by the derivative of the inside. The derivative of 5x is 5. Always in my head, I always think about take the derivative of the outside, leave the inside alone, then times it by the derivative of the thing you just left alone, which is the inside. So you get that. And if you want to make it a little bit prettier, 5 f prime 5x. That'll be my answer. Next one. How many times must the chain rule be used for each? So in this case, we just got to try to figure out how many times we're going to use the chain rule. So in this case, I'm just going to use it once. Take the derivative of the outside, then just inside, and you're done. The next one, look, if I take the derivative of the outside, I have this inside here, but that has a chain rule in itself. So that's going to be 2 times. The next one, take the derivative outside. The outside is actually the radical. The inside would be all this. And then the derivative of that would be cosine, so that's twice already. But on the inside of that, we still have this thing that we had last time, so I'm going to need at least 3 times to do that one. Right, because the radical, then the cosine, then the 4th power. So those are all going to be chain rules. We call that a nested chain rule. The next one, well, this one looks a little funky, but you take the derivative of the outside tan, which is once, and then you get to this guy, and the derivative of that's also a chain rule, because it's e to a power. Now, I'll be the first one to admit, I don't really think of e as chain rule so much, because the way I do e is I copy it times by the derivative of the power. That's how I do it. But it's technically a chain rule. Next one, suppose that f prime of 4 equals g of 4 equals g prime of 4 equals 1. So all these is equal 1. That's all that's saying. Do we have enough info to compute f prime of 4 where f of x equals f of g of 4? So this is a constant trick that AP uses. They'll say, hey, compute this, but this equals that. So really all we're doing is taking the derivative of this guy. That's all we're doing. Then we're going to sub in 4. So they're saying, hey, take this, but that equals this guy. So really just taking the derivative of this guy. And that's a chain rule. So let's see if we take a derivative of that. This is how we talked about before. Take the derivative of the outside. Derivative of f, easiest thing in the world, f prime. Leave the inside alone, g of x. Remember, that's a bad parenthesis. Then times by derivative of the stuff you just left alone. I just left g of x alone, so times by derivative of that, g prime of x. That parentheses messed me up. There we go. A little bit better. So we have that. Now again, we have to plug in 4. So it'll be f prime of g of 4 times g prime of 4. Now do we have everything we need to find out what this is? So I need g prime of 4. I do. That's 1. I have a g prime of 4. Do I have g of 4? I do. That's g of 4 is 1. Now keep in mind that's the inside of this. There's still the f prime on the outside. So I get down to here, and now I need f prime of 1, which we don't have anywhere. So we actually don't have enough info. Not enough info. Need f prime of 1. So that's how that goes. Next, we're just going to take some chain rules. So remember, take the derivative of the outside, leave the inside alone, times by the derivative of the inside, or times by the thing you just left alone. What I use sometimes, I think it helps people. So take the derivative of the outside, derivative sign is cosine, you can memorize that, leave the inside alone, times by the derivative of the thing you just left alone. So you get that, or if you want to be math literate about it, you get this. Keep in mind, you cannot, this is not, I see some people give me cosine 2x to the third. Remember, this part is locked in. Cosine of, like, it's a function, so that cannot ever be tampered with. That's stuck, so this can only move to the front. The next one, remember the tricky one, sine squared of x? You want to write this as sine of x squared. I mean, I still do this when I take a derivative. Now it's just a chain rule. The outside's the squared part, so bring that down, subtract 1 off. Right, that's the outside of it. Bring the 2 down, subtract 1 off. Sine's left on the inside. Always leave the inside alone. Then times by derivative of the inside, or thing just left alone. So cosine. So there we go. If you want to make it a little nicer, you could write it like this, but it's all the same. There you go. 24. I want to rewrite that before we do anything. So we get this. Now it's just a basic chain rule. So we're going to bring the 1/2 down, subtract 1 off. So I get 1/2. Common denominator. Negative 1/2. Leave the inside alone. Then times by derivative of the inside. Derivative of the 1 goes away. Derivative of this is negative 2t. And if I want to simplify it a little bit, 1/2 times negative 2t, the 2's will cancel. So you just get negative t times 1 minus t squared to the negative 1/2. Now that's good if it's I mean, this is honestly good if it's a free response. Now if it's multiple choice and you don't see this answer there, click your inner algebra and like simplify this. So if it's multiple choice, I would have to flip this guy down. So it look like this. It would be 1 over square root, because 1/2 is square root, 1 minus t squared. And then there's a negative t on the outside. So I guess if I was going to do it like really nicely, this would probably be the multiple choice answer. It would be something like this. Again, free response, feel free to leave it like this. If it's multiple choice and you don't see that answer there, you got to simplify it a bit, and it'll probably be this answer right there. 25. This is kind of a clear chain rule. So here's my inside, here's my outside. Take care of the outside, bring this down, subtract this off. So I get negative 5/2. Subtract 1 common denominator. Negative 7/2. Leave the inside alone. Times it by derivative of the inside. So derivative of that. Now it can't be sloppy here. Don't just write, like, a lot of people just do this. 2t plus 3. Make sure you put parentheses, because otherwise when you try to combine it, you're going to mess yourself up. And that would be my answer. There's not really much I could, if it was multiple choice, I'll make it I could simplify it, but we're good. Next one, sine of x squared plus 4x. Again, this one should just be a clear chain rule. Now you're like, okay, my outside sine, take derivative of sine. That is cosine. Leave the inside alone. Then times by derivative of the inside. Again, keep in mind, don't be sloppy. Derivative inside should be 2x plus 4 in parentheses. If I want to move that to the front here, but keep it in parentheses, not much difference. Next one, chain rule again, bring it down, subtract 1 off. So 2/3, subtract 3 over 3, negative 1/3. Leave the inside alone. times by derivative of the inside. So that'll be 4x cubed minus 3x squared. Simplify this for the multiple choice, like if this wasn't on there. This will have to move down. This gets to stay on top. So it looks like this. 2, 4x cubed minus 3x squared. 3 is on the bottom, and then this got moved to the bottom, so it'll be the cube root of x to the 4th minus x cubed minus 1. Or that's still 1/3, either way. Next one. So another chain rule, my tan's on the outside, derivative tan. A lot of people mess this one up. Okay, so it is a little, secant squared is not that bad. So derivative tan is secant squared. Gotta remember how to do that. Leave the inside alone. Remember these are thetas, not zeros. Then times by derivative of the inside. Now theta here is just like your x. So theta, it's like the derivative of x is 1. So derivative of theta is 1. Plus the derivative of cosine is actually negative sine. So negative sine of theta. And there we go. That's my answer. E's. Now again, I think E's are easy. All you have to do is, I don't even think about chain rules so much. Most parts, I just remember, okay, with an E, copy it, then times by derivative of the power. And there you go. I'll make it a little prettier. 2x e to the x squared. That's all I think. That's all I think about with these. Next one. Tan. So again, this is like kind of put together. So we just kind of did one like this. Secant squared. Leave the inside alone. Times by derivative of the inside. There we go. Next is x cosine 1 minus 3x. Notice there's two separate x's. This is the product rule. Inside that product rule, we're going to have a little chain rule right here. But this is generally the product rule. This is like my f. This is like my g. Some people like to separate it. They'll put like f is x. F prime is 1. G is cosine 1 minus 3x. G prime would be negative sine of 1 minus 3x times negative 3. Little chain rule. So you could like kind of do it here, then kind of assemble it all together over here. That's one way to do it. I just kind of know the formula. So derivative of the first one, x is 1, times the second one left alone. Plus the derivative of the second one left alone, that is a chain rule. So it's me derivative cosine is negative sine. Leave the 1 minus 3x alone, times by derivative of that, which would be negative 3. Now, when you get to here, though, a lot of people tend to forget, like, you're not done. You still have times by the first one left alone. So times it by x. Like that. I can make it a little nicer. I mean, just make that side, again, if it's multiple choice, make that side more palatable. Multiplying negative sine times negative 3 times x, so it's a positive 3x sine of 1 minus 3x. Again, only if it's multiple choice. For your response, you feel free to leave it like this. Next one. Oh, it's already rewritten for us. So we just got to take a basic chain rule. 1/2. Leave the inside alone. Subtract 1 off, so minus 1/2, because it's like 2 over 2. Times by derivative of the inside. Or the thing you just left alone. 4. I guess I can simplify that a little bit. Multiply these guys and I get 2. Now, if it's multiple choice, this will be on the bottom. So if it's multiple choice, I'm practicing, that gets something like this. That'll be my answer. The equal sign's a little funky now. There we go. So that's the free response answer. Multiple choice answer, you probably have to rewrite it to make it look like that. Sine of cosine of theta. So, chain rule, outside right here, take derivative of sine, which is cosine. Leave the inside alone. So I'm going to leave my cosine alone. Times by derivative thing you just left alone. I left cosine alone, so derivative of that is negative sine. Now watch out here, this is not cosine squared, right? This is cosine of cosine, so you can't really do much with this one. If I want to make it a little bit prettier, I can make it a negative on the outside, maybe negative sine theta, cosine theta. But that's like not that much nicer. Next one. So it looks like a basic chain rule. Bring the 4 down, subtract 1 off, so I get negative 4 x cubed plus cosine x to the negative 5 times by derivative of the inside. Derivative of my inside here, each one separately. 3x squared minus sine of x. Don't forget parentheses. So something like that. Again, so how does it look on a multiple choice? That wasn't the answer. Well, the negative 5 has to move down, so it looked like this actually. Negative 4 times 3x squared minus sine x over x cubed plus cosine x to the 5th. And if you don't see that, then they probably distribute the 4 inside. It'd be like negative 12 plus 4 sine. But something to this effect to look closer to the multiple choice. 42. Now it gets fun. Look at this one. This is a nested chain rule. Right? See how it's sine into all this stuff? Trick is just work your way outside in. So take derivative of the outside, which is sine. Derivative of sine, sorry, is cosine. Leave the inside alone. I'll try to do this in 2 different colors. So I'm going to leave the inside alone, which is cosine sine of x. Right? So I left that alone. I have to leave something alone. Times by derivative thing just alone. So we're going to times by derivative of this guy. Derivative of cosine sine x. So what's the outside? Cosine is. So take derivative of cosine, which is negative sine. Leave the inside alone. So the inside is sine also. There we go. Right, so, and I'm not done yet, by the way. So take derivative of the outside, sine is cosine, leave the inside alone. This was my inside. Take derivative of this guy. This is the chain rule, so take derivative of the outside, derivative of cosine is sine, negative sine, leave the inside alone. Times by derivative of the inside. The derivative of my inside here is cosine. So that's all my answer. All of that. I can make it a little nicer. I think not really. I mean, I put the negative of the outside. That's basically all we can do. So my answer here is going to be negative cosine of sine of x. Look how many parentheses I need. Then I have, oops, the last parentheses looks ugly. Sine, it's times by sine of x times by cosine. All of that. So it's a nested chain rule. Take derivative of the outside, cosine, leave the inside alone. Times by derivative of the inside, so derivative of the thing just left alone. All this, which is itself a chain rule. So derivative of outside is negative sine, leave the inside alone. Times by derivative of the inside, cosine. Next one, look how many x's you have. X squared times tan of 2x. There's 2 x's. So this is a product rule to start off with. So you have this guy and we have this guy. Derivative of the first one, 2x times tan left alone, tan of 2x left alone, plus the derivative of this guy. So remember, we want to, helps if you put a little parenthesis here so you can see it. So this is a chain rule. Derivative of tan is secant squared, leave the inside alone, times the first one left alone, x squared. Like that. Next one. Now again, so like doing like this, you might get it wrong. You want to rewrite it. So that's cosine squared. So that's the same thing as saying cosine of 8x squared. And this is another nested chain rule. What's the outside? Outside is a squared. So we're going to bring that down. Subtract one off, so I get this. Then I want to leave the inside alone. Inside is cosine of 8x times by derivative of the thing you just left alone. So I just left cosine 8x alone. So I got times by derivative of that. That itself is a chain rule, right? Derivative of cosine is negative sine. Leave the 8x alone. And then times by derivative of the thing you just left alone. 8. Right, so take derivative of the outside. 2 down, subtract 1 off. Leave the inside alone. Times by the derivative of the inside. That's a chain rule. Derivative of cosine 8x is negative sine 8x times the derivative of the inside. 8. So that'll be my answer. You can make it a little nicer. I would get negative 16 because the 2 and the negative 1 and the 8. Cosine 8x. Sine 8x. And actually, for pro, this is a double angle formula, actually. But they won't go that far. That'll be fun. That'll be good enough. Next one. 10 3x plus 10x cubed. So these are different types of the same thing. So this, we're going to rewrite it. So this is tan of x cubed plus tan of x cubed. Right? There's an emphasis that was different there. So the key here is, right, this one is done this way, and this one's done this way. So I have this problem here. So this is a chain rule where you bring the 3 down, subtract 1 off, and then times by, so I brought the 3 down, subtract 1 off, got 2. Leave the inside alone, and then times by derivative of the inside. Derivative of tan is secant squared. plus, now we're going to take a derivative of this guy. Right, so it's like two separate problems, just kind of combined. That's all a plus does. This outside, and this one, the outside is tan, so derivative of tan is secant squared. Leave the inside alone, which is x cubed, times by derivative of the inside, 3x squared. So we get that. 52 is more the basic one. Just want to rewrite it first. 4 minus 3 cosine of x to the 1/2. Now we just got to take a derivative. Bring the 1/2 down. Subtract 1 off. So 1/2. 4 minus 3 cosine of x to the negative 1/2 times the derivative of the inside. Derivative 4 goes away. Derivative of that is negative. Actually, derivative of cosine is negative, so positive 3 sine x. Right? Derivative 4 goes away. Derivative of cosine is actually a negative sign, so it becomes a positive 3 sine x. Again, I can make this a little nicer if I want. Let's combine the 3 sine x and the 1/2, and then flip this to the bottom. So it'll be 3 sine x is on the top. On the bottom we have the 2, then we have this flipped, so I'm going to put square root 4 minus 3 cosine x. So that's as nice as it gets if you're trying to simplify it for multiple choice. So next one is 61. So these are E problems. Again, for me, E's should be the easiest thing in the world. They're always done the same way. Copy them and then times by the derivative of the power. That's all we're doing for E's. So I'm going to copy it, and then times by the derivative of the power. Over here, same thing. I'm going to copy it, then times by the derivative of the power. And then from there, I can simplify it a little bit. This is negative 4e to the negative x minus 14e to the negative 2x. And there we go. Again, for me, E's are the easiest thing in the world. Same thing with this one. E to the tan x. Copy it, and times by derivative of the inside. Derivative of tan is secant squared. So there we go. Next one, we have a table we could use. We're going to simplify this. So just like before, okay, maybe besides E, I think when I give you f and g, that should be the easiest derivative. Then it's E. So E second, these are first. Because the derivative of f, you don't have to memorize anything. What's the derivative of f? Just f prime. Right, so it's a chain rule. I should start off with that, right? Take the derivative of the outside f, derivative of f prime, leave the inside alone, times by a derivative of the inside. So like that. Right, so take the derivative of the outside f, just f prime, leave the inside alone, then times by the derivative of the inside. Derivative of g, just g prime. Now we're going to sub in 6, so I get f prime of g of 6 times g prime of 6. And then all these values are in the table. So g prime of 6. So here's g prime, here's 6. So this is 3. This one we want to watch out for, g of 6. So here's 6, here's g, so it's 6. And now we have f prime of 6. So f prime of 6 is 4. We just get 12. Right, so remember when you do compositional functions, you do the inside first. So what's g of 6? G of 6 happened to be 6. And then do f primes of that value. So I got 4. 4 times 3 is 12. Same to the next one. Hey, look at it. It's an E and F, the two easiest ones. Right? Remember the way we do E's? You copy it, and then times by the derivative of the power. Derivative of the power. F prime of x. Okay. And then now we're going to sub in the 4. So I get e to the f of 4 times f prime of 4. Right? We're just plugging in the 4 for the x. So we have this. Now we use the table. F prime of 4. So f prime 4 is 7. F of 4 is 0. So it's e to the 0. E to the 0 is 1. E to the 0 power is 1. And I get this. Just like that. So 7. Move on to the next one. This is another chain rule. Take the derivative of the outside. Leave the inside alone. Times by derivative of the inside. Now before we times by derivative of the inside, you gotta let's rewrite that just so it's a little easier for us to work with the derivative. Right, so I haven't taken derivative yet. That's just me rewriting it so we can take a derivative. So the actual derivative will be take derivative of the outside, g prime, leave the inside alone, times by derivative of the inside. So bring the 1/2 down, subtract 1 off, like that. And now we're going to sub in 16 to everything. So g prime of 16 to the 1/2 times 1/2 16 to the negative 1/2. Well, 1/2 power is just square root. So this is g prime of square root of 16, which is 4. Now here, don't make an algebra 1 mistake. Remember, it's PEMDAS, order of operations. Exponents go before multiplication. So right here to be multiplying, here will be an exponent. So you do the exponent first. So square root is this is a square root function, so it's 4, but then the negative flips it, so it's actually 1/4. So it's like this, right? Because that negative flips it down, then it takes square root of 16, so you get 4. G prime of 4, I don't know what that is. G prime of 4 is 1/2. It's all fractions here. So 1/2 times 1/2 times 1/4. Remember, all you do is multiply them. So 1/4 times 1/4 is 1/16. So there we go. Over here, so we're taking the derivative of this. Is it missing? No. Okay, so I was confused if it was like 2x. Okay, so it's f of all this is in my inside. So it's a chain rule. So take the derivative of the outside, which is f. So f prime. Leave the inside alone, which is all of this. That's what I was like looking at in the beginning. Times by derivative of the inside. So derivative all of this would be derivative that's 2 plus the derivative g of x is g prime of x. Remember, those are always the easiest derivatives. Don't forget, keep it in parentheses, right? These are combined. It's not times 2 then plus g. It's together. Now we're going to sub in 1. So 1 goes here, 1 goes here, 1 goes there. So I'm just going to rewrite it so we can see it. So that's 2 plus g of 1 times 2 plus g prime of 1. I need g of 1 and g prime of 1. G of 1 is 4, g prime of 1 is 5. So this is 4 and this is 5. So I get f prime of 6, 4 plus 2, times 2 plus 5. So f prime of 6, f prime 6 is 4. So 4 times 7 is 28. So there we go. Moving on. More ease. I think this page we just did. Okay, I'll edit that out of the worksheet. 83. So d2 dx. So we want the second derivative of this. So the second derivative of this guy right here. So the second derivative one time. So d of dx would be a chain rule. So I'll take the derivative of the outside, which is sine, so cosine. Leave the inside alone. Times by derivative of the inside. Let me simplify that a bit. 2x cosine of x squared. Right, I want to put the 2x in front. So again, remember, this is locked in. You can't mess. Anytime you see a parenthesis like that, it's stuck. You can't do anything. So I wrote it like this. What do we do now? Take the derivative one more time. Now, look how many x's you have there. Right, 2 separate x's. This is a product rule. When you do that, though, there will be a little chain rule right here. Right, the chain rule is on this side. So, product rule. Second derivative would equal the derivative of the first one, 2, times the second one left alone, plus the derivative of the second one, that's our chain rule. Derivative of cosine is negative sine. Leave the inside alone. Times by the thing you just left alone. Right, that's all the derivative of this guy. All of this is just the derivative of this guy. Don't forget to leave this guy, multiply by this guy left alone. And again, free response, you're done. You can walk away. If it's multiple choice, you want to clean it up a little bit. There's nothing much you can do on this side. But on the right side, I have a negative 1 times 2x times 2x. I get negative 4x squared sine of x squared. And that'll be my answer. Next one, same idea. They want you to take the second derivative of this. So the first derivative, just the chain rule, so bring it down, subtract 1 off. So I get 5x squared plus 9 to the 4th times the derivative of the inside, which is 2x. Right, times the derivative of the inside, 2x. Simplify a little bit, so I'm going to combine these two. So I get 10x, x squared plus 9 to the 4th. And then next, I want to take the second derivative of this. So we're going to do it one more time. And again, if you notice, 2 separate x's, so it's a product rule. So d squared dx squared. The derivative of the first one is 10 times the second one left alone, plus the derivative of the second one, that's the chain rule, so bring the 4 down, subtract 1 off, leave the inside alone. Don't forget to multiply by derivative of the inside. Derivative of the inside here is 2x. then times it by the first one left alone. Right? The part with the chain rule is always the hardest because a lot of people tend to forget to multiply by that guy because you did so much work just to get this part. Not done yet because we got to simplify this. Now, this is mostly going to be on the multiple choice, and they mostly have the answer simplified. So that's why I'm going to ask you this on the quiz and test to practice simplifying this. Now, it's not as bad as it looks. The key here is these big guys. You can always factor out one of these guys, most likely. So in this case, I could factor out x squared plus 9 because they both have it. Remember, you can only factor out the smallest of the two. So I can factor out x squared plus 9 cubed. That's gone, and there's only one of these left over. Now, do they have anything else in common? Well, this has a 10 in front, and this has a 10. So we factor out a 10. And then what's left over? That's gone, that's gone. On this left side, I have x squared plus 9. Plus, on this side, I have 4 and 2x, that's 8x. Some people put parentheses here that you could, but all you're doing here is adding now. So you just combine like terms. There's really not much you can do on that side in this case. So I get x squared plus 8x plus 9. And that's it, simplified all the way down. So you will see this on a quiz or a test, and most likely on the AP exam. It will be one of these on the multiple choice, but we want you to simplify all the way down to here. Next one, we want to get the third derivative of this. So let's take the first derivative. So my first derivative would be, bring this down, subtract 1 off. So I get 11 3x plus 9 times 10, right? So bring it down, subtract 1 off, times by the thing left alone. 3x plus 9 to 3. Right, so all I did was bring it down, subtract 1 off, leave the inside alone, times by the inside. If I'm going to simplify this a little bit, I could get 33 3x plus 9 to the 10. So that was the first derivative. Now we're going to do the second derivative. Oops, sorry, x. Now the second derivative, you don't have to freak out. Look at the problem here. There's only one x still. It's still just a basic chain rule, not a product rule. So it's another chain rule. Bring the 10 down, subtract 1 off. So if I bring this 10 down, I get 330, 9, and then leave the inside alone. Times by the inside 3. If I simplify that a little bit, I get 330 times 3, which is 9990. Right, so I'm going to get 990, 3x plus 9 to the 9. So I get my final derivative, right, multiply 9 times 990. I use a calculator, I don't know that off the top of my head, that's 8910. Then subtract 1 off, right, so bring 9 down, subtract 1 off, leave the inside alone. Times by the inside. And if I want to simplify all that, multiply the 3 and the 90. I'm using my calculator again because I can't do that in my head. 3x plus 9 to the 8. All the way worked out. A few more. I'll take the third derivative of sine 2x. I know we did all that work. This one will work out a little easier. So the third derivative of that, just take the derivative one time. So the outside is sine, so I get cosine 2x times the derivative is 2x. So I get 2 cosine of 2x. That's the first derivative. Then take the second derivative. So this is d of dx. I mean, you can also write, I've been writing like that, but you can also write like this, like, hey, we still have 2 more to do. So right, I've been writing it with the equal sign, which is just saying, okay, the third derivative is this. That's totally fine. You can also do it this way, which is saying they took the third derivative and got this, or they took a derivative and got this. There's still like 2 more to, there's 3 derivatives that go. Now there's 2 more to go. Derivative, this would be, derivative cosine is sine, so negative 2 sine of 2x times 2, so negative 4 sine of 2x. Right, so this would be the second derivative, and then you still have one more derivative left to take, so you can write like this, and that would equal negative 4 cosine 2x times the derivative inside 2x, so I get negative 8 cosine 2x. So there you go. Again, not as bad. I think it's a little cleaner when I write equals to let you know which one's which, but either way works. Compute the second derivative of sine dx at x equals 2, assuming g of 2 equals pi over 4, g prime of 2 equals 5, g double prime of 2 equals 3. So here's sine of gx. So we just got to take a derivative. So remember, take the derivative of the outside. Derivative of sine is cosine. Leave the inside alone. Times by derivative of the inside. So like that. I gotta take a derivative one more time. Now keep in mind, like how many exits you see. All right, 1, 2, two separate exits. So this is a product rule. So I gotta do this one times this one. The derivative of the first one. We just said derivative of cosine is negative sine. Leave the inside alone. Times by derivative of the inside. Now watch out, right? We're doing this to derivative that's the derivative of the first one. We still haven't times by this guy left alone yet. So times by that guy left alone. Remember the product rule? Derivative of the first times the second plus the derivative of the second times the first. So all this was just that guy, right? That's a chain rule. So derivative of cosine is negative sine. Leave the g of x alone times by g of x. So we have that. And then I have to times it by this guy left alone, which is right here. So then plus the derivative of the second one. Derivative of g is first derivative. Now we do second derivative, double prime of x, times the first guy left alone. Like that. And now we're going to sub in 2 to everything. So negative sine of g of 2 times g prime of 2 times g prime of 2 plus g double prime of 2 times cosine of, oops, it's a bad cosine. Cosine of g of 2. Like that. And what do they tell us? G double prime of 2 is 3. So this guy is 3. G prime of 2 is 5. So these are both 5. And then g of 2 is pi over 4. So this is pi over 4 and pi over 4. So I normally would show an extra step, but we should all know what sine of pi over 4 is, right? It's rad 2 over 2. It's a classic one. So this is negative rad 2 over 2 times this plus cosine of pi over 4, same thing, rad 2 over 2. So over here I get negative 25, these are all over 1, over 2, rad 2, sorry. Let me erase that. I get negative 25 rad 2 over 2 plus this over 1, 3 rad 2 over 2. And then I could add those two and get negative 22 rad 2 over 2. And that's it. And that's the worksheet.